We are Team Robinho, and we are creators of a brand new educational solution. We have identified the problem that teaching robotics to middle schoolers can be quite a hassle. In today's hyper-connected and technological world, we have the challenge of stimulating interest and teaching newcomers into the technological area. This problem becomes exacerbated by the need of various tools and structures that sometimes even the teachers may have difficulty navigating. Our solution comes in the form of Robinho, a friendly little robot that presents a streamlined and user-friendly interface for all purposes. With Robinho's teaching method, our students can log in to our website through any web-capable device. Through this website, they are also allowed to receive all feedback from the robot and also make their own codes in a block-based programming language. For the teacher, it becomes as simple as accessing their dashboard on the same website, where they can see all the code that has been submitted by his students, and then he can review and grade them. After each code test, Robinho then goes back to his original position and he's ready to receive new code for testing. With Robinho, we believe our teachers will be able to focus on teaching robotics, and our students can focus on exploring and having fun. The project is made of many smaller parts that integrate into Robinho. On the user side of things, we have the web app and its web interface, which can be accessed from anywhere in the world. On the other side, we have Robinho's environment, which is composed of a large 4-meter squared arena, a ceiling camera for visual feedback and detection, and an entirely custom-made robot agent, which is Robinho, the star of the show. And finally, the brain of the operations is our server. The server is housed right into Robinho's environment, providing all sorts of interface for the environment and hosting the web application. The web application frontend was made possible with Bootstrap, and it integrates into Google's open source block-based programming environment. It also contains a list of progressively more complex tasks, explores all of Robinho's features, and allows the student to assess and solve them individually. The arena structure is made entirely out of plywood. It has a magnetic charging point to allow Robinho to stay always charged. It also contains its own microcontroller, which allows the arena to control its own logic for certain tasks. It has a large maze section which is made out of styrofoam, which allows Robinho to explore his environment in a more controlled manner. Our camera employs a custom-made computer vision solution to detect where Robinho is at all times and to send arena streaming information to the web app. Robinho has his own power source, 2 powered wheels, and a collection of sensors. He has a claw-like actuator and his own point-of-view camera. Robinho connects to the server via Wi-Fi, and using MicroPython he can be recoded at any time.